I'm going to show you some PVC pipe that's ran on 1% slope, and then I'm going to show you some PVC pipe that goes to 3% slope. And we're going to show you what happens to PVC when you do this, and I'm going to explain it. I'm also going to explain the greenhouse effect. You can see how there's condensation on the top of this pipe. That's because the air is colder than the dirt that's around it. This pipe doesn't vent. If this was a French drain where it only had holes on the bottom, it would not vent. So when you hear me talk about the greenhouse effect in PVC pipe, what I'm referring to, PVC pipe only has holes on the bottom. There's typically only 2 holes on the bottom, but you can seek out 3 holes. That's the max, because then the pipe becomes too weak. PVC is really brittle and it cracks. If you put holes 360 degrees, PVC will fail. Now, the greenhouse effect that I always refer to, now when I talk about the greenhouse effect, you have the holes on the bottom, whether it's 2 or 3, they're facing down. There's nothing to vent this pipe. So up top in this pipe, you end up with a lot of condensation buildup. When the temperatures change, there's nothing to vent this pipe up top. So it builds condensation. Anytime you have a change in temperature, you're going to move air through the system. Now the ground is going to stay a certain temperature for a while. It doesn't change as fast as the air. So you get condensation at the top of the pipe. There's many things that grow in the dark when you have a non-vented system. So when we have holes 360 degrees, we vent our pipe for French drains. We don't have condensation building up in the top of our pipe, growing all kinds of things. Red algae, iron ochre, these things thrive when you have this greenhouse effect. When you have corrugated pipe that's 4 slots staggered, or you have 8 slot, you end up with inlets and outlets 360 degrees all the way around the pipe. The top, the bottom, the sides. This pipe's going to vent. All right, let's continue on with our inspection. You can see all the condensation. You can see the greenhouse effect occurring. You can see how this just stays damp, and it's never going to dry out. It's never going to vent. If you have certain soil bacterias with French drains, they just love this. So this is a solid discharge pipe, but it gave me an opportunity to teach that. And I wanted to show you what this looks like when this pipe goes from 1% slope to 3% slope. So there's a reason why all the inspectors are checking the plumbing in homes so that it's 1% slope. If it's any greater than 1% slope, what happens is you end up with a situation where the water leaves the pipe too quick and it drops any solids. We have a crack right here. You can see there's a split right where I circled it there. There's a break. Now that'll cause a sinkhole. A discharge line in PVC, when it cracks like that, the dirt falls in. Now when you have a gutter drain or some pump discharge line run, it's going to pump that water out. See what's growing on the top of this pipe? I don't know exactly what's growing on the top of this pipe. I just wanted to point it out. So this is caused by the greenhouse effect. This is a solid discharge line. Again, it just gave me an opportunity to speak on this, but I want to continue to teach you guys some other things that I find when using PVC pipe that you have to be careful with. So when you go from 1% slope to a drop-off in the yard, this happens a lot in yard drains. You can't just run PVC pipe at 1% throughout your entire yard. We have some really steep grades in certain areas in Michigan. I know Tennessee, Kentucky, the Carolinas, you're dealing with a lot of valleys and ridges. So this pipe had to go on 3% slope right now. What happens is the water leaves too fast. Now, do you see all the shingle gravel that's in this pipe? Why is that? Well, there's a couple reasons. One, it didn't have a catch basin to help filter it out. That would have helped. But it went from 1% slope to about 2.5% slope. PVC has to be on 1% slope all the time. And that's impossible to do with yard drainage. You're going to have 2% slope, 3% slope, even 4% slope. This is why home inspections say you have to have 1% slope. When you flush your toilet, if you don't have 1% slope, it will not push the solids out. It'll build up, it'll clog, and that's what's happening here. This pipe couldn't maintain 1% slope. The grade fell off. It had too much fall. Now, corrugated pipe, you can run single wall corrugated pipe on 2% slope, 3% slope, 4% slope, no issues, because the corrugations create a turbulence along the pipe's surface. It suspends all this debris and carries it out to the discharge. Now, I'm running the camera through here because they reported problems and asked if we can come and provide a service and figure out what's going on. This is going to have to be jetted out. It's clogged. You can see there's some leaves, some organic material in with the shingle gravel. So, again, keep your PVC pipe at 1% slope. If you can't, you need to run single wall corrugated pipe. And you have to watch your dual wall pipe as well. If you can run it on 1% slope, you'll be fine. But if you can't maintain 1% slope through the design of your system, because you have drop, a lot of drop, you have to run single wall corrugated pipe. So I tried to push the camera through this clog just to see how bad it was. I can't get the camera through it. So the camera's on a cable. Normally I can push through a clog. This thing's jammed up pretty good. So we're going to have to come and jet it out. This was not a belly. This was not a belly. This pipe had no bellies in it. Through this inspection, that's not what we've seen. We know from the outside grade what we're dealing with. And this was a far run over some distance. And yes, anytime you go from 1% to 2%, you're going to have problems. Unless you're running single wall corrugated pipe. That's your other option. And this pipe, with its crack, there's probably some dirt also falling in. And once it hits that 2.5% slope, it's not pushing the dirt out. It's not pushing the shingle gravel out. Anything that it was carrying in the water, it loses. The water evacuates too quick. It won't carry the solids away. A lot of mold and mildew in this system. Again, a French drain system that doesn't vent at the top is going to do the same thing. So this was a great opportunity for me to bring up and show a couple of things. Now we're starting to come back to 1% slope here. You can see that there was some shingle gravel lost, a little bit of debris as it was going from 1% to 2.5%. But we're clean here. We're clean. Everything's the way it's supposed to be. So that's why the home inspector, the building inspector, makes sure all indoor plumbing is ran on 1% slope. When you have a smooth bottom pipe like PVC, it has to be at 1% slope. A lot of condensation right here. You can see it up top, just building up. You know, this is a discharge line for a downspout. But if it was a French drain, they look the same. I'll get video footage and I'll share it with you throughout the year. I'm looking forward to educating and teaching everybody about the differences. So we're looking really good here with this 1% slope. So we had to run a camera through some other PVC pipes, and I video recorded that for you guys as well. So here's another pipe. You can see that this pipe has breaks and it has cracks. Now this yard had a lot of sinkholes. Anytime PVC pipe separates like this, where you see the breaks, you have your breaks, a lot of cracks, and then right here you got separation. That's catastrophic failure. and dirt's going to end up in the discharge line. Every time it rains or the sump pump turns on, pending what the pipe is used for, the dirt that falls in the pipe is going to get flushed out the discharge end. It's going to create sinkholes in the yard. Now, there's a lot of cracks in this pipe. This pipe's in really bad shape. This is another downspout line that's ran. I wouldn't run it in the south. I wouldn't run PVC outdoors, period. I like corrugated pipe. But this one is in the north. It is in the frost. It sees a lot of heave every time it freezes. You know, the ground lifts and then it settles. PVC pipe is rigid. It cracks. Look at all the cracks throughout this pipe. It's amazing that this pipe, that they're able to still use this pipe. You can see cracks on the sides, on the top, even on the bottom, some really big cracks. Catastrophic failure. You're starting to see separation. This is causing the sinkholes in this yard. Anytime you have settling of the ground, shifting of the ground, PVC pipe is going to crack like this. Look at that big crack in the bottom of this pipe. So corrugated pipes, flexibility is its strength. You're never going to see this with corrugated pipe. It's going to allow you to run on 1%, 2%, 3%, 4% slope without any issues. The pipe performs really well. If the ground shifts, it doesn't crack. Its flexibility is its strength. A lot of people think with a downspout on PVC, they don't need something to catch the leaves. They don't need something to catch the shingle gravel. Nothing can be further from the truth. You're going to end up with problems. You're inviting problems by not using a leaf filter, by not using a catch basin. So I wanted to point something else out too. You see all these cracks in this pipe. The cracks are on the bottom, they're on the sides, they're on the top, they're everywhere. There's guys that are openly talking about drilling more holes in PVC pipe when they use it for a French drain. They'll take a pipe that has 3 holes on the bottom, and then they'll make 3 more holes on top. This pipe is so weak when it comes to that type of thing. You cannot add inlets to the top of the pipe. If you're going to use PVC for a French drain, I strongly suggest you don't, because once the bottom of the holes fill up with dirt or sediment, and it's going to happen, that's just the natural progression of a French drain. Over time, it fills up with dirt. There's a little bit of sediment on the bottom. Corrugated pipe with inlets 360 degrees, it'll continue to work for you, where a PVC French drain will not. If you drill holes in it, it's too brittle, it's too weak, and it's going to fail you. You can just see all the cracks in this pipe. This pipe is no good for the north. It has to be ran on 1% slope. It can't be any greater than 1% slope, or it's going to leave all the debris behind. Now, people always say, well, PVC is easier to install and to get your 1% slope. If your grade is falling away and you have a lot of drop, you have to stay with the grade. What are you going to do? If you don't drop the pipe at the 2 or 3% that the grade is falling, you're going to come out of the ground with it. It's going to daylight too soon for you. When you're trying to discharge it further away to prevent erosion, say on a bank, or a hill. Yes, you're trying to get it down below where there's not going to be any erosion or any issues. You don't want to discharge water up high in a grade. You want to carry it further away. Man, this looks like job security to me. This pipe has to come out. New pipe has to come in. If you appreciate the videos that I take time to make to help educate everybody on the different materials, what they do, using indoor plumbing materials on the outdoors for yard drains, things like that, Give me a thumbs up. It shows me that you appreciate the time that I'm putting into these videos. If there's any videos you want me to make, leave it in the comments section. Welcome to the French Drain Man channel. I'm your host, Robert Sherwood. In this video, we're going to talk about the two different types of pipe that you have to choose from for a French drain system. The first pipe we're going to talk about is the PVC pipe. Let's talk about all the different things you have for choices, things you have to look forward to if you run a PVC pipe. I want to make sure to mention all the pitfalls so that you have success if you do choose to run PVC pipe. Now, PVC pipe comes in two perforated pipes. That's it. The choices are only two. This one happens to have 3 rows of holes in it. The other option is 2 rows of holes. The 2 rows of holes would have the hole to the left, the hole to the right, no hole down the middle. A lot of people believe the hole going down the middle weakens the pipe. If you have a hole here and a hole here, you maintain the structural strength of this pipe. You add another hole here, another row of holes here, and you can possibly weaken the pipe. When you drive a lawnmower on this pipe, you don't want it to become brittle so that it cracks. So keep it in mind. Now, this pipe is designed to where its holes go down. The holes are on the bottom of the trench. So you don't want to put any holes in the sides. You don't want to put any holes in the top. You're going to make the pipe too brittle. This pipe is too subject to cracking. So you just want to keep it the way the manufacturer, perforates it. So if you got the 2 holes or the 3 holes in rows, you want to put those down. The water rises up into the pipe and then it's carried away. When sediment builds up in the bottom of your French drain trench, and it will, and it does, it is just the progression of any French drain. There's going to be some sediment in it. The sediment will basically cover the bottom of the pipe, and you'll lose about this much of your pipe. So take a look at that. You're going to lose about that much of your pipe. The water is going to flow up here where the pipe has a greater diameter. So it doesn't really hurt your flow rate. But what it does hurt is your perforations. When there's sediment in the bottom of this pipe, it no longer can take in water. That's a problem. So you can jet this out and you can clean this out to help reduce the amount of sediment. Unfortunately, you can't do anything about the sediment that's on the outside of the pipe in your French drain trench. As it slowly works its way up into the pipe, you can jet it out that way. You'll notice that the performance of your French drain will be less and less as the months go by until you have to jet it out to pick that performance back up again. Now, the other thing you have to be cautious about with PVC pipe can only be ran at 1% slope. There's a reason why home inspections require that your pipe is ran, your indoor plumbing, at 1% slope. If PVC pipe is ran on a 2% slope or greater, the fluid will now outrun any sediment or solids that's in the water. Anything that's suspended in the water outruns, it just falls and gets left behind and it builds up. So you have to run this pipe at 1% slope. You cannot run it at 2% slope. If you have a yard that at some point your French drain is going to be ran on a downhill slope that's going to be greater than 1% slope, that's where this pipe is going to clog. The water will outrun all that sediment and debris that it's carrying, and it'll just be left in the pipe, and it'll just build up until it clogs. So keep that in mind. Now, another thing that I've noticed with PVC pipe is that it builds up a lot of condensation inside. Because it has holes only on the bottom, this pipe is not allowed to vent up into the stone. All French drains should be full of stone. So if you have holes in the top of this pipe, it can now vent, which reduces the greenhouse effect that this causes. So because there's only holes on the bottom and there's no holes on the top and the sides, this pipe will usually grow iron ochre, red algae, a lot of bacteria that grow in the dark and wet, damp places. That'll happen more frequent. You'll need more frequent cleanings, and it brings a lot of additional maintenance cost. So you can run 2 French drain pipes so that it kind of betters your chances with some of that. But the only problem I see with running 2 pipes side by side in a trench is once there's sediment in the bottom of the French drain trench, both these pipes have holes on the bottom. So once there's sediment on the bottom and all the pipes, both pipes are plugged and those inlets are clogged and they won't flow water anymore, it's pretty much useless. And when you jet it, it'll never work 100% like it once did, because there's going to be still sediment in the stone outside of the pipe, and you can't do anything about that. All right, so that's enough with that pipe. I taught you a lot about that pipe. What goes into installing that pipe? It must maintain a 1% slope. You do have to be mindful about the greenhouse effect. If you know you got iron ochre, red algae, and there's so many other bacteria grown, so many things that are in our soils that, you know, plague French drains, and you just really got to watch that. So you got to think about that. Is this pipe the right choice? And if you're unsure about your soil bacterias, you might want to go with a different pipe to kind of cover that. So let's talk about corrugated pipe next. So corrugated pipe, it has holes on the top, on the bottom, on the sides, 360 degrees. You can see all the perforations. It has a lot of inlets. So what's nice about corrugated pipe, you could run it on 1% slope, 2% slope, 3% slope. This pipe shines at 2 and 3% slope. There's turbulence right here where the pipe has these ridges and valleys. Those ridges and valleys create a turbulence in the flow of water just at the surface of the pipe. The turbulence isn't up in here. It's just right at the surface of the pipe. So it suspends anything that's sediment or debris. This pipe absolutely shines at 2%. It absolutely shines at 3% and even 4%. So you don't have to worry about running it on 1%, 2%, 3%. If you have some fall in your yard and you're not really sure what you have there, you can be rest assured the corrugated pipe is going to perform flawlessly for you. Now, once the sediment fills the bottom of the trench, and that could take a couple years, it might even take longer than that, depending on how you build it. If you want to put stone under here, you can kind of hold off that sediment buildup, as the sediment will fill the voids of the stone opposed to the bottom of the pipe, but eventually it'll always make its way up to the bottom of the pipe. So right here at the bottom, you don't flow a lot of water. You flow all the water right here, the rest of the pipe, at its greatest diameter. So once the bottom holes are clogged and they no longer can take in water, and you can see these 2 bottom ones are closer together, where the PVC, it's further apart. So once this is clogged and these 2 are clogged, no big deal. Now we have the ones that are safely out of the sediment, up the sides. Look at it, it's all the way around, 360 degrees. Either you have a 4-slot staggered or an 8-slot. You don't want 4-slot in a row. You want 4-slot staggered or 8-slot. You're going to see perforations really, really close to one another. Like these rows are not far apart. And this happens to be our 8-slot. We really enjoy that pipe and its performance. So you don't have to worry about the slope that you set this on. You don't have to worry about the sediment buildup in the bottom. The pipe's still going to take in water from the sides and from the top. And the other thing you don't have to worry about is the greenhouse effect. You don't have to worry about all that additional. And don't get me wrong, you're still going to have bacteria that'll grow in a corrugated pipe. But it's not going to be due to that greenhouse effect where it really accelerates that whole process. The things we find growing in PVC pipe because it doesn't vent at the top. Because remember, the pipe, if it would vent like corrugated, where you have holes on the top, you have all that stone that you put on top of the pipe. And especially if you went with larger rock on top of the pipe, it's really going to vent well. And you shouldn't see any like bacteria growth of any kind. Mold and mildew build up in PVC. It's just the way it is. You got that greenhouse effect, that dome, and it just really builds up. Don't see that in corrugated pipe. All right, everybody. If you found this helpful, give me a thumbs up. It shows me that you appreciate the videos that I'm putting together. I recently ran an inspection camera through some PVC downspouts. I want to show you what I found. We have a lot of cracks in this PVC pipe. Right here, that is catastrophic failure. We see it all the time in PVC. We're going to have to tear this downspout out. We're going to have to run it in corrugated pipe. It's a gravity drain for a downspout. It's in the frost. What's going to happen is dirt is going to keep pouring in from these really bad cracks. You can see there's more over here. We got tons of cracks throughout, but we're starting to see some failure here. Some real failure in this pipe. Oh, here's another area. Yeah, that's really bad. So what happens is the dirt's going to come in from these areas that are cracked really bad. And as the dirt falls in to the pipe, when we do get rain, it washes it out to the discharge. This is what's causing all the sinkholes in this yard. Wow. It just keeps getting worse. Look at that. Man, this pipe is in bad shape. Just busted up. This is what happens to PVC pipe. This is schedule 40. Look at this. God. Yeah, this is for sure what's causing all the sinkholes. It's washing all the dirt out. A lot of cracks. And that's going to cause more collapse. You're going to have more areas where dirt's falling in, collapsing inside, and being washed out to the discharge end. You know, PVC is a great indoor pipe. It shines indoors. God, look at all the cracks. Look at all the cracks. There's some leaves right here. So you always wonder, do I really need a leaf filter? I don't know, you decide. Here we are, we're in a smooth bottom pipe. Everybody wants to criticize corrugated pipe. Look at this. Like that is a massive buildup of leaves. I don't know if I can push it out with the camera or not. No, we lost our camera. Let's take a look inside a corrugated downspout system. Here in the north, we do not like running PVC in the frost. I just showed you why. I don't care to run PVC anywhere. In the south, in the north, It's just prone to cracks. But you can see in this corrugated system, here's a not quite a 90. We're going down inside this downspout. You see how the not quite a 90 doesn't let debris fill up right in that elbow? It's ramped and it pushes all the debris right through the system. I'm going to plow the camera through this not quite a 90 and take you on a 41-foot tour of a corrugated system. So everybody wants to criticize corrugated pipe because it has ridges and valleys. And they say, oh, the ridges and valleys are going to trap debris. Well, if you have a leaf filter, you catch all the big organics. If you have a catch basin, you catch all the shingle gravel. Here's an FDM catch basin. It's the only catch basin on the market that when it freezes solid full of water, your pipe still drains during a thaw. Basically, it was just common sense. You keep the basin a basin. The top portion represents the pipe, and it's put on the same slope as the pipe, so it always drains out. This was deliberately done. This was one of the details, one of the requirements when we built the catch basin. It had to be able to freeze up in the winter and still flow water during a thaw. No other catch basin on the market can make this claim. They all freeze up like a big bucket, like a 5-gallon pail out in the yard full of water. They just freeze solid. So the camera does a pretty good job of correcting itself, but right now you can see the bottom of the pipe is to the right. This is a 3-inch system, by the way. Now we're on the verge of freezing at the time of this inspection. And we had some light rain. So there is a small flow of water going through here. And the rain does pick up through this inspection. You'll see some water flowing. And I want you to pay really close attention when you see the water flowing through this corrugated pipe. Look at that. I love the harmonic motion of water through a corrugated pipe under a low flow. If you study cohesion and adhesion of water, you'll understand why it moves like that. Now, if you have a high flow, it's going to create turbulence near the wall of the pipe, and that's going to cause self-cleaning. If you have a low flow application and you never see a high flow of water, you'll end up with debris filling in those low valleys in the corrugations, and the bottom of the pipe becomes a smooth bottom pipe. These are just facts. This is 38 years of experience going through drainage systems with inspection cameras, and I just wanted to share it because there's so many misconceptions. I just want to bust some of those myths. The flexibility of corrugated pipe is its strength. The ground can shift and it doesn't crack. Vehicles can run over it. It has the ability to deflect and then come back to its original shape. When you drive over ground with a tractor, with a vehicle, the ground moves. The more moisture that's in the soil, the more it'll move. And the ground will actually spring back up. Corrugated pipe does just that. There's a lot of secret ingredients in virgin HDPE. The different ingredients will do different things. Some are hardeners that'll add more strength and it'll make it more rigid. But if you add too much of that ingredient, you'll end up with a pipe that will crack like PVC. And there's some other ingredients. There's other recipes out there for virgin HDPE where the pipe becomes very elastic, allowing it to fully rebound right back to its original shape near 100% after some pretty serious deflection. Now, another myth that I'd like to bust, people think that this turbulence, you end up with this turbulence through corrugated pipe, and it disrupts the flow so much that it really, really reduces the amount of gallons per minute that pipe diameter is supposed to put out. The turbulence is at the pipe's surface where those ridges and valleys are. But through the center of this pipe, when you have a heavy flow of water, it flows no different than the water's flowing through a PVC pipe. So these misconceptions, yes, can you have a higher flow rate with a PVC pipe versus a corrugated pipe? Yes, the answer is yes. But to what degree? It's just at the pipe surface that there's turbulence. I've seen the flow tests. We spend a lot of money here at French Drain Man to see what all these parts are doing. We have a lot of prototype parts, and before they get in the hands of the homeowner, we make sure that everything's 100%. And I'm here to tell you that in the center of all these corrugated pipes, there is no disruption to the flow of the water. There's no turbulence. You're pushing a lot of water through the pipe is what I'm trying to say. The rain had picked up, and you could see that there was a continuous flow of water. I was trying to get this done before the rain, and it was going to change over to snow. We were on the verge of freezing. I just wanted to get this footage. I wanted you to see this. This is an actual downspout system. It's installed, and this is what it looks like when you go through the inside of a 3-inch. This is an FDM 3-inch Pro Kit, and it's 41 feet long, so it does have some extra pipe on it. Now, I'm in the pop-up emitter at the not quite a 90, and I'm going to push the camera up until we hit the bottom of the pop-up lid. There it is. That's the inside of an FDM pop-up lid. Now, I'm going to try to push the camera up and out of the pop-up itself. I'm 41 feet away. I'm at the downspout up at the house, and I have an inspection camera. You can see Made in America, Made in the USA, that said. That's the inside of our pop-up lid. And you can see the grass there a little bit. I daylighted the camera. Now, I'm going to pull the camera in reverse, but I'm going to go through this really quick. I think this is going to be better for you, especially when we get to the catch basin. The camera does a pretty good job of correcting for itself. So the bottom of the pipe is never at the top of the screen. It's either to the left or to the right. It does self-correct at times. But you can see the rain has let up quite a bit now. You don't see the water in the pipe that was flowing before. Not as much anyways. Slowing down. And when we get to the catch basin, I want you to pay really close attention to that gap. The catch basin didn't have no holes in it. We didn't want the catch basin to leach water near the house because it was a sand soil. If you drill holes in your catch basin and you have highly permeable soil and your catch basin is close to the house, which I prefer to do that. I like to have a catch basin that's 3 feet from the house. We don't drill the holes when it's really permeable soil. You're going to lose too much water at that catch basin up near the house. Our catch basins are designed to where they can freeze up. I'm in the catch basin right now. Camera, as we were backing out, fell down into the gap of the catch basin, and there you have it. You can see that's 100% 3-inch open hole, not compromised in any way. Our entire system is made out of 100% virgin HDPE, the pipe, the leaf filter, the not quite a 90, the pop-up emitter, all of it. It is meant to freeze up, it'll expand, it'll contract during a thaw, and it'll work for you 100% without cracks. That's why we got away from PVC, and that's why we love HDPE, high density polyethylene. I wanted to give a proper intro to the video footage that you're going to see in this video. We did have a tear out. It was of a PVC system. In a previous video, I showed how when PVC is on 2% or more slope, it drops the sediment. The water outruns the debris that it's carrying in the water. PVC has to be at a strict 1%. In areas where you have 2%, 3%, 4%, PVC is going to clog. This is an example right here of a bunch of shingle gravel that is built up. I'm going to show you a system that's a 6-inch PVC system. It was ran on 2% slope. The water outran the sediment that it was carrying. And the sediment continued to build up in this 6-inch PVC pipe. To add to it, PVC pipe only has holes on the bottom. So once the debris filled up the bottom portion of the pipe, it no longer had any inlet to take in additional water. Now, when we're tearing out this PVC system and I'm showing it to you, I mention in the video clip that you're going to see next that we're going to save that PVC. And the reason why we're going to save that PVC pipe, we'll run 4-inch corrugated pipe in some old, torn out PVC from a failed French drain system. We'll run it under a driveway that way because it does have a mighty crush rating. So we repurpose the old French drain pipe that we tear out and we use it as a raceway underneath driveways. All right, everybody, I hope you appreciate all the video that we're putting together. If you like this video, please give us a thumbs up. So we have a PVC system that we ripped out of the ground. PVC only has holes on the bottom. Let me show you what this looks like. You have a row of holes on the center of your trench. Then a little off center, another row of holes. A little off center, another row of holes. So this is best case scenario. If you have the PVC that has the 3 lines to take in water. Now, this was on 2% slope. And everybody wants to say, oh, PVC pipe doesn't silt up. Well, I don't know what to tell you guys, because this system cost the community tens of thousands of dollars. Now, our high octane pipe, it has 8 inlets, 360 degrees all the way around the pipe. All the way around the pipe. Big inlets, the largest inlets in the industry. You cannot find a pipe with more inlet than the high octane. So let's get you guys back to the basics, to the next part of the series, where we're going to go over failure, what failure looks like, and how to prevent it. We're replacing a failed French drain system. What failed on this was the fact that they used PVC pipe. To make matters worse, they didn't use a good non-woven geotextile filter fabric that's double punched in a 4-ounce to 8-ounce. We're going to take this pipe out, we're going to cut it, and we're going to take it back. Because I'll use PVC as a sleeve, I'll use PVC for different things. This is a 6-inch pipe, this is expensive material. We'll make use of it. But outside of that, there's nothing wrong with it besides the fact that it was applied to an outdoor French drain system, which we preach not to do. Once it got sediment in it, let me explain what happens. Once it gets sediment in it, there's 3 holes on the bottom. So the center hole is pointed to the bottom of the trench. That plugs right away. I mean, that plugs like pretty much immediately. So you're flowing less water already. Now you just got the 2 side holes that come up on the side, flowing water until the sediment builds up and it starts to restrict them. When you're not moving enough water through the pipe, you no longer can flush sediment out of it. As we talk about all the time, see how there's no holes? Only on the bottom. See, corrugated pipe has holes 360 degrees all the way around. So it's always going to flow water. On those really, really hard rains, those torrential rains, those thunderstorms, it'll literally flush out any sediment. Now we wrap ours in a 4-ounce to 8-ounce non-woven geotextile filter fabric that's double punched, so we're not going to have any issues. But unfortunately, when you use PVC pipe with only holes pointing down and you have no fabric wrapping the system, unfortunately, that is just a disaster waiting to happen. This system ran for 2 years only. The community paid good money to have this system put in. PVC is not cheap, and it lasted 2 years. So the community, they had to live with this thing not working for years before the HOA was able to collect enough money and a new board came around with new ambitions to do their research, to find French Drain Man, our recipe, our blueprint. They understand it. They know the truth behind PVC pipe with only holes on the bottom that point down. You don't have holes 360 degrees, so you can't take water in. Once there's sediment on the bottom of this pipe, you're done. And if you don't use a really good non-woven geotextile filter fabric. The sediment's going to find this pipe that much quicker, and it's done. All right, everybody. Until that next video.